Hi everyone. So we've already started taking a look at user-defined data types, and in this video we are going to be looking at enumeration or enums as we call them. And what enums allow me to do is basically just give some word to a number. That's in a nutshell, that's what enums are. So let's just say I want to do something like this. I want to create a boolean. So I say boolean, and let's just say I want to store the state of my light. So light state. And if you don't know what booleans are, they're basically just uh, it's a whole system based on just zeros and ones, or off and on, or true and false. That's all there is. And next, what I want to do is I want to give it, let's say, 0 or a 1. So the light state can be 0 or a 1, so it could be off or it could be on. That's what booleans mean. But I don't really want to use 0 here because that can be confusing, let's say. So what I want to do is I want to use let's say on here or off, uh, and that's what we're going to be looking at. And even at this point, if I save this program and I try running this, as you can see, it says unknown type name boolean. So it doesn't recognize this thing right here. So what I want to do is I just say I just use the word enum, and then I give this enum a name. So I say boolean, and then within braces I give what the possible booleans are. So in this case I want, let's say, off and on. So these are the ones that I want, and I'm just going to follow convention which says that since these off and on are just constants, they should have they should be in all caps, and that's what I'm going to do. So let's just try it now. And just one small thing that you need to add here is the word enum before boolean. So every time I want to use boolean, I have to say enum boolean. And let's try it now. As you can see, it compiles all right, and then I can do something like off. So my light is off right now. And then I can also do something like this: if light state equals on, then let's do a printf light is on, and otherwise let's print light is off. And let's try it now, and let's do enumeration, and as you can see, it says light is off. So that's basically what enumeration allows us to do. And what it's internally doing is just assigning a number to this off. So let's just try something else. I can do if light state equals 0, and then I write off here, and this is on. And let's just try this out. As you can see, it prints light is off, which is this one, which means that it actually went inside this if block. And the reason that happened was because 0 is the number assigned to the first value that I give here. So basically what it's doing is something like this. So it's starting from 0, then it's giving a 1, and if I had something like another state here, it would give it a 2. So that's how it works. And not just how it works, I can actually even write it like this. So let's go ahead and try it out again. So as you can see, it just runs the same, and it doesn't give me any error here. So what I'm saying is, for the number 0, the word off is just equivalent to 0. The word on is equivalent to an integer 1. The word other is equivalent to the integer 2. So we're just giving these integers a different name, and then we're also creating a boolean, which is basically a variable which will only take one of these values right here. So that's how booleans work. I can also do something like, let's say, enum day, and then I give it Monday, Tuesday, Wednesday, Thursday, Friday, Saturday, and Sunday. And let's just get rid of this, and I write enum day d1 equals, let's say, Wednesday. And then I can do a check if d1 equals Wednesday, then print it's a Wednesday. um, it's a Wednesday. And we can try this out now. So as you can see, it says it's a Wednesday. But now what I'm going to do is I'm going to say that assign 1 to Monday, and then I just don't say anything for the rest of them. And let's see what this prints out. I can actually even print an enum. So let's just print the day number, and I give it d1, and let's go ahead and try it out. As you can see, it prints 3 now. So if it had just followed the normal numbering, it should have given me a 2, because this would be a 0, this would be a 1, this would be a 2, and so on. So instead of a 2 here, I get a 3, and that's because I've already given the number 1 to Monday. So what it says is you've already given 1, so I'll just do a +1, +1, +1, and so on to name the other uh, constants that you have here. So I can also do something like, I can do Wednesday, Thursday equals third day. So I can do something like that. And let's try it now, and I'll give this a Friday, let's say. And let's try it out now. So this didn't give me a result because I've still got Wednesday here, so I need to change this to Friday. And let's go ahead and run it now. As you can see, it gives me a 4. So basically what it does is it says, okay, I'm assigning 3 to Thursday, and then I just do a +1 from there on. And from this, one thing you might have noticed is that this Wednesday got a 3 as well, and this Thursday got a 3 as well, because Monday was 1, so Tuesday would be 2, Wednesday would be 3. So what happens in cases like these is, let's say I give it a Wednesday, and then I check for a Thursday. Let's go ahead and try it out. As you can see, it still gives me the number 3, and that's because these both got the same integer 3 right here. And all we're doing in enumeration is just giving different names to integers. So although I'm perfectly allowed to do something like give a 1 here and then a 3 here, which is kind of mismatched, but then I need to be careful of mistakes like these. So that's how enumeration works. And one last thing before we close this off, I can't have something like this. I'm creating another enumeration called state, and I give it off and on. And let's go ahead and try running it, and what happens is that I get a compilation error. And basically it says that I'm doing a redeclaration of enumerator off as well as on. And that's basically a precautionary measure that the compiler is taking, because here I'm not going to be using, I'm just going to be saying off, and the word off could mean different integers based on here and here. Although in this case I'm just assigning off as 0 in both cases, but there's nothing stopping me from doing something like this, and that would totally mess up the program. So that's one thing that I can't do. However, if I just move this inside of a different function or something, so let's just say I get rid of this. Let's just say I move this inside of main, and I move this to inside another function. So I create some function void foo, and then within this function I create this enum right here, and I save this. Let's try compiling it. So as you can see, it just compiled fine. That's because both of these have different scopes now. So basically inside of main, if I write the word off, that would mean a 0, and inside of foo, if I write the word off, it would mean 100. So that's how it's going to take this. And if I create another function, um, and I try to use the enum here, it's just going to stop me from using the enum at all. Um, let's say I do off and I try running it, it'll say that it doesn't know what off means, or it doesn't know what state means. So that's something I can't do because these now have limited scope from here to here, and this one has a scope from here to here. So that's it about enums, and we'll talk about unions in the next video, so stay tuned for it.